Everybody, how you doing? This is Mr. Dowse. This is my second video on solving equations. My first video I did was over adding and subtracting numbers to a variable and solving these kinds of equations to solve for x. This video is focusing specifically on when you're multiplying or essentially kind of dividing a number that's next to the variable and how to handle those kinds of problems. But this is a one-step problem, so there's only one thing you need to do to solve these problems. And these are focusing on just step 4. The next few videos I want to do are going to be more challenging and involve all or most of these steps. But specifically right now I'm going to focus on using multiplication or division to cancel out the coefficient in front of the variable. And a coefficient is just a number in front of a variable. So 7 is a coefficient here, negative 3 is a coefficient here, negative 1 is a coefficient on number 3. So how do we cancel those out and solve for x? That's what we're doing here. So looking at number 1, I have 7 times x equals 49. And whenever you're trying to solve an equation, again, your goal is to try and figure out what number can I plug into this variable to make the left side and the right side balance out. So what times 7 will equal 49, or what times negative 3 would equal 9, and so on and so forth. So what you do here, to cancel out whenever you're multiplying a number by the variable, you do the opposite of what you're actually doing to the problem. So this is multiplying, but to cancel out 7 times x, I need to divide the left side by 7. And whatever you do to one side of the equation, you have to do to the other side to keep it balanced. And so if I'm dividing the left side by 7, I need to divide the right side by 7. And what happens is 7 over 7, if you don't remember, a number divided by itself simplifies down to just 1. So I end up with 1x equals, and if you take 49 divided by 7, you get 7. And if you plug that in the calculator, you get 7. But typically, you don't see a number, 1, as a coefficient in front of a variable. So that 1 actually can be ignored. And I end up with just x equals 7 is my answer. You can put 1x equals 7, but it's best practice to just leave that 1 off and leave it as just an x. And so I'm going to check my answer here. I'm going to plug this variable back into the original equation to see if it balances out the left side and the right side. So I'm going to plug in a 7 for the x. So what's 7 times 7? That's 49. Oops. And so that balances out. So I know that 7 has to be the correct answer here. Moving on. Number 2, I have negative 3x equals 9. So it's negative 3 times x equals 9. So our goal is to figure out what number can I multiply negative 3 by to get to 9. So again, same idea we did on the left one here, on the first problem. Whatever is in front of the variable, that coefficient, you're going to end up dividing by that number. And if you divide that on the left side, you have to do the same thing on the right side. And so again, any number divided by itself simplifies out and equals 1. So I have 1x equals, and then 9 divided by negative 3 ends up being a negative 3. And if you don't believe me, just kind of plug it in the calculator just to kind of make sure. Yeah, I got negative 3 here. So that's what x ends up being. So if x equals negative 3 is the right answer. And from now on, I'm not going to worry about having a 1 here. I'm just going to write down the variable because, again, the 1 in front of the x, we can really just ignore that. So I'm going to check my answer here and make sure that this is the right answer. So I'm going to plug in a negative 3 for that x. And so I have a negative 3 times negative 3. Well, negative times negative is a positive, and 3 times 3 is 9. So that does balance out. Now, typically, you're not going to have, I have a 7 as a coefficient here and a 7 here and a negative 3 and a negative 3. That typically doesn't happen. That's just kind of an example. Let me come up with a different problem here. Kind of prove my point here. So let's say I have, 5x equals 40. So if I want to solve for x here, again, I'm just going to divide the left side and right side by the coefficient. And the 5 over 5 cancels out. It's going to end up with an x. And then 40 over 5 becomes 8. And if you wanted to check your answer here, you could do 5 times 8 equals 40, and it balances out. So that works out. So it was just a coefficient. It was just a coincidence that the coefficients in the first two problems match the answer. That's typically not going to be the case. So number 3 that I have here is an unusual situation that I felt like I should put on here because I think a lot of people would get confused. So if I have a negative x equals 4, that negative is implying there's a negative 1 in front of this. So this is really like a negative 1x equals 4. You need to do this because you're not going to end up dividing by a negative sign. You need a number on the bottom when you divide. So now that I convert this negative x to a negative 1x, I can divide by a negative 1 here. And so the negative 1 over negative 1 will cancel out and just leave me with x. And then 4 divided by negative 1 is just negative 4. And just to double check that you believe what I'm doing here. So if I do 4 divided by negative 1, I end up with a negative 4, and that's what I got for x. So if I plug, let's do negative 1 times negative 4, because x is really a negative 4. And I were to multiply negative 1 by negative 4, well, negative times negative is a positive. 1 times 4 is 4. So I end up with a positive 4 equals 4, and that's what I was looking for, so that checks out. That's my first video on multiplying and dividing. I'm going to do another video where I'm dealing with decimals and with fractions. So I'm going to stop this video and I'll start another video here. It'll be part 3 of these kinds of problems. So let me do that. So have a good day. Bye-bye.